Welcome to yaymath.org's presentation of Yay Math in Studio, standing in the beautiful YouTube Space headquarters in Los Angeles, California. I'm Robert Adut, and this is Yay Math, where we feature math video lessons taught in front of a live class. So normally, I'm in front of live students and we're having our interactive moments and our laughter and our engagement, but I thought that it's more important to have a complete program, and that if the fill-in-the-blanks videos I couldn't get to it in class, or if there was a moment in class where we couldn't film, I'd rather have a complete program to supplement the library. So here we are in this beautiful studio space, and we're talking about a few things that are awesome. I mean, the need to create and share is too great, so I wanted to be here and create that for you guys. So let's just jump right in. Yay Math! The first lesson that we're going to do is on perimeter. And perimeter is actually a good place to start because it's something that's logical and intuitive and conceptual. But sometimes the books and the system at large forces us to do it with formulas, and that's not always so inspiring, and it's not always easy to remember. So I want to show you ways that you don't have to do it with formulas. You can just sort of use your common sense and use your brains, right? Because we're all people here just trying to work things out, okay? So the basic definition of perimeter is the distance around a shape. So you can put that down, distance around the shape. Essentially, the way to do that is to add up all the sides. Add all sides. So this part of the definition will be important. We're going to come back to that, about whether we can always do that, okay? So, I mean, a simple shape to start with would be a square. So if I had a square here, implying a square that all four sides are the same, and let's make up something like 8 here, right? So what would the perimeter be, right? If this was 8, then we can imply that all sides are 8. I would encourage definitely, write in as much as possible. You want to cue your brain to fill in different pieces of the puzzle. Even if a problem like this is somewhat obvious at the beginning, it's a good habit to get into. Just cue your brain, trigger your brain to think of things like, oh, this is 8. Oh, this is 8. I'm going to write it. I'm going to write it. Okay, so now we have it. 8 is great, and so we can get that perimeter. So the perimeter looks like it's 8 plus 8 plus 8 plus 8, or 8 times 4. So that's, we can even do 4 times 8, and that would be 32, okay? Units or whatever, okay? So what's the formula now? Now that we've done this intuitively, I would like to talk about the formula with you. Can you say what it is? Can you think about it, right? If we want to call this a side, right? So let's say the perimeter is this side plus this side plus this side plus this side, or even 4 times the length of the side. So that's the formula that the books give, 4s. Now, here's the overriding theme of this particular video. Don't sweat having to memorize this. Don't worry about memorizing, right? Memorizing isn't, it's not compelling. It doesn't work, right? It doesn't work unless there's a reason to. You're welcome to, and it might actually happen when you let it go, and it might stick. But don't start with the formula for learning how to do math, right? Better to just do it intuitively and see, oh, I can see that. Whatever the side is, you multiply by 4. Whatever the side is, you multiply by 4. And you're going to see that more and more. Let's do a different shape with a different color, like a rectangle. Do something like that. You can give this like a 10 and a 4, let's say. So what's the perimeter of this guy? Again, we're going to cue our minds. If this is 10, then this is 10 in a rectangle. If this is 4, this is 4. We add up all the sides. Here we go. So that perimeter, we can make sort of intuitive strides here. These two together make 20. These two together make 8. So 20 plus 8, that would be 28. Now what's the formula? After we do it, right? Let's figure out how to get the formula. So the perimeter, could you say it's 2 of these, boom, boom, and 2 of these, boom, boom? Probably. And what do we do with those? We add them. So we could call this the length of the rectangle. We could call this the width of the rectangle. So we have the length of the rectangle. We're going to add the width of the rectangle. How many of the lengths? 2 of them. boom, boom, and how many widths? 2 of them. So there they are. So what I'm doing is really intentional. I'm not leading with this, okay? It's really important. I'm not leading with this. I'm leading with you, common sense, and then we'll conclude with this so that it's all like connected, tied together. Let's do triangle, you know. Do something like this. 6, 7, 8. Add up all the sides. So the perimeter equals 7 plus 8, that's 15. Plus 6 is 21. We can do a parallelogram, you know, all different types of things. In a parallelogram, it's safe to say that the opposite sides are the same. So boom and a boom, boom and a bang, whatever you want to say. Let's do like 8 and 2. So again, right, so if these are both 8, these are both 2. Let's have a little fun. Boom and boom. That would be 10. That would be 10. Together it's 20. Add up all the sides, and we're good to go, okay? Now let's get into another shape in which we're not calling it the perimeter. Okay. For many years, I was baffled as to why we don't call this perimeter as well. Maybe you know that the perimeter of a circle is called the circumference. Circumference. The circumference of the circle is essentially the perimeter. And then I looked it up. I was like, why do we need a fancy word for this, for the perimeter, right? And it's like a C, starts with C. And I always think of C like the crust of a pizza. C is the crust, is like the length all the way around. I don't want to get too hungry, so I'm going to stop talking about the pizza thing. It's too late. Growl. So why does it have a different name? All right, and it has to do with this. The clinical definition of perimeter is add up all the sides, add them up. But I see no sides, so we need a new definition. So there's your answer if you're ever curious about why there's a different name for this thing. And so this thing also has a formula, but we're not going to lead with it because that's what we said is the theme of today. Here's the way to do it then. Did you know, were you aware, and it's kind of amazing, no matter how big or how small the circle, this line called the diameter, that blue line there, right there, this thing, this line called the diameter has a certain relationship with the outside, with the crust, with the circumference. It turns out that if you take this line, let's say, imagine it was a piece of string, and I lifted it off like whomp, and then I had that diameter line right here, and it's sort of squiggly and bendy, and I put it around the edge, it would fit, like there's one, right? Definitely need more. I need more diameters. Let's do it again. Let's get another one. I can extract it because it replenishes. And then maybe call it 2, coming around. Something like that. Now, I need more. Oh, there it is again. Nice. Twizzlers. So take it back, or a blue Twizzler, that is. Let's put another one down. So it goes around. There it is. There's the third wrapping. Oh, and a little more. Oh, so it turns out that if I want to get the circumference of the circle, all I would need to do is basically take that diameter and multiply it by 1, 2, 3, and a little more. Like roughly 3 of those. Roughly 3 diameters would be the circumference of a circle, but it's like actually more than 3. It's about 3.14, a wink, if you've heard of that number. So that magical ratio, that magical number, no matter how big, the circle could be the size of Wisconsin, the size of a marble. It could be as big or small as you want, a planet, all the way down to really like a microscopic circle. You can fit 3 and a little more diameters around the edge. So if you want to get the edge or the circumference of the circle, that thing is called, oh, check it out. We could turn this into pi. There it is. 3.1415, on and on and on and on and on. That irrational number, that crazy number that goes on and on without ever stopping, is the number of times that the diameter fits around the circle. And so pi times diameter is the length of the entire circle, right? The circumference. So that's why this formula exists. You may see in other books and such, you could say, or, that the whole length is diameter. So I could say that half of it, the length of this guy, maybe you know, is called the radius. So radius is half the diameter, right? So then if this is the radius, then this is also the radius. So then it would be safe to say that there are 2 radii in one full diameter. So they're equivalent. So I can bring my pi down. And if I wanted to split the diameter into 2 radii, they split the, they put the numbers in front, these coefficients they're called, they put them out in front. It doesn't matter where you put pi. You could put 2r pi, it doesn't matter. But basically this 2r is equivalent to the d. Now, personal opinion, I like pi d. There's less calculations, it's one long line, and you're not doing 2 times this times that. You're just doing whatever the diameter is multiplied by pi. So let's get some examples going. La 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 la. La la. Oh man, the diameter is not in the middle. That would be a non-fair diameter in the pizza slice, you could say. My half! Here we go. It's a little better. So suppose the diameter was 10 inches. This circumference is pi times the diameter. This circumference is pi times 10. And so many times on the standardized tests, maybe SAT, ACT, they're going to just ask you to leave it like this beautiful thing, 10 pi. But if you're required to bang this out on the calculator, this would be 10 times 3.14, 10 times 3.14 for rounding. And 10 times 3.14 is actually 31.4. And then the units in question are inches, because that's 31.4 inches all the way around, right? So you could think of this like a garden or a putting green or whatever, what have you. Maybe it wouldn't be inches, it'd be more like feet. But yeah, that'd be 31 inches around if your diameter was 10, okay? Let's do one where I give you, not the diameter, but the radius. 8. So let's say the radius was 8 centimeters. You get the drift. We could say pi times diameter. Diameter in this case is how long? 16. 2 of these. So that's pi times 16. And then 16 pi, right? So if I wanted, personally, I think you could just chill, leave it at 16 pi centimeters, right? So that's an elegant way of doing it without necessarily needing the calc. But, we could do it with the calc. So I got the pi button on the phone. Boom. Boom. Here we go. Okay, so we have 16 times pi equals 50.27 rounded centimeters. 50.27 centimeters. There you go. So that'd be one way to do it, okay? Now, what if we did this? Leave that on. So this is pi times d. So I did some research, right, because I love to play basketball, and I was thinking of that free throw line. So if we have like an image of hoops here, so let's say this is the area called the paint or the key within basketball. Let's say this is the hoop right here. This is looking top down, like if you're on the roof or on the ceiling, like looking down at the basketball court. And you have this thing here. This is a semicircle, okay? And that this length here on the high school and college level is 12 feet. This is 12 feet wide, this thing, okay? And so the question, I get to use pink now. Here we go. Use the pink action. Try not to disrupt too much with the black. So just to outline it. There you go. maybe you notice that that pink shape is a semicircle, and what if I wanted this perimeter? So that makes it a fun challenge because it's not a full circle, and we have a line to contend with. So the full perimeter in this case, we'll go back to the P word, because now we can add up some sides in a way. We can definitely say 12 plus, right? 12 plus this thing. And would you agree that this is half the circumference? So if it's half the circumference, we could do like, why not? We could say instead of pi d, what's half of d? Radius. We can do pi r. That would be kind of fun. Or another way to look at it, I'll come back to pi r, just like this. We agreed, or 2 pi r, remember that? So these are the two ways of doing the circumference. So if this is the full circumference, if we divide this by 2, 2 divided by 2 goes, and there it is, pi times radius once more. So there we go, 12 plus pi times whatever the radius is. And this will be the circumference of that semicircle. And the radius in this case is not 12, because that's the diameter. Radius, I'm going to put it in like I said before, is 6. And so there it is, 12 plus 6 pi feet, right? Or if you wanted an actual feet measurement, let's see, hopefully the phone's still, yeah, cool. I like reset the settings so it wouldn't lock on me for moments like this. So 6 times pi, you could do it with me at the same time, equals, I did 6 times pi plus 12. Boom. 30.85. 30.85. All right. 30.85 feet. Let's try to keep the units going because that demonstrates that you know what we're talking about. It's how long this is. 30 feet around. Okay. I hope that helped get some introductory, concepts on perimeter. And we're going to do a couple more videos here. So thanks for being with us. Thanks for watching A Math. We'll see you next time.